Okay, I'm going to go ahead and get started since it's noon apparently. And this is going to be a special presentation because I get to do it this month. I wish that Elizabeth Cooper was here. She's our new interim director, and she's actually taking over BSUG planning with the help of Dylan there in the back, if any of you would like to meet him later. So I would love to introduce her today, but she is out of town at a conference. She should be here for the next BSUG talk, and our next three are not finalized, but it's looking like these I have up on the screen: Corey Squire from Lake Plato, Roderick Bates from Curie and Timberlake, and Jacob Dunn, our very own Jacob Dunn from Askew, Dumas, and Ripple. Should be the next 3 months BSUGs, and if you're all on the newsletters or emails, you should hear more about that. And if you're not, we can get you signed up pretty easily, or you can sign up at our website. So with that, and I'll introduce myself since I'm usually the introducer. I'm Katie Licklider. I've been here at the lab for 2.5 years now. Background in mechanical engineering. I was at an MEP firm for about 3 years before this. And since being here at the lab, I've been doing simulation as well as some tool development and technical assistance type work. So with that, I will share one of our tools that we've been working on for a while now. We're calling it the heat pump calculator, or the heat pump energy savings calculator. And what I'm hoping to get through today is just a little background about the tool, how we developed it. I'll show you the tool itself. And then the part I found the most interesting was some loads comparisons we did through eQuest and EnergyPlus. And then along with those loads comparisons, I have what I'm calling a preliminary energy consumption comparison, and then some next steps in discussion. And I do want this to be open, so if anyone has any questions along the way, please feel free. And just to double check, are we recording this statement? Okay. Always forget, so like to make sure. So as far as the background, in 2012 we did a BSUG market assessment, and basically to find out how our local industry here felt and views simulation. You can see the animations. You can see that time and money were basically the two things that were preventing people from using simulation in their design. And then some reasons they were using it was as a design tool, which we like to see, and then because clients request it, or it's needed for LEED certification. So we really like to see it used as a design tool and not kind of as an afterthought for LEED or other certifications. And we would like to see the design community promoting it rather than waiting for the client to request it too. So with that, we thought a heat pump calculator tool might be useful to mitigate some of the time and cost issues that people were finding with simulation, so that we could get some quick results but still good data. So with that in mind, we looked at we tried to find all the existing tools we could, and we came up with a list of 9 that fit some of our criteria. You can see we listed the year they were developed, if it was available. Most of them were Excel-based, but not all of them. We looked at residential versus commercial use, and what kind of equipment, whether the load calculations were simplified or whether they were detailed. And then same on the energy calculations, whether those had been simplified or not. And then we looked at performance levels, if those were available in the tool, some cost information, and if the tool had comparative capabilities. So you can see there on the matrix, most of them had a variety of those, but not all of them. And we hoped to get in and make a detailed tool that could give you some cost and savings numbers pretty quickly without too much effort. So, like I just mentioned, we wanted to develop a calculator showing energy and cost differences between what we went with were ASHRAE baseline systems and then a few heat pump technologies. We wanted it fast and easy, reasonably accurate, and then we left the tool to be very transparent, hopefully so people can understand what they're getting out of it if they'd like to dig in deeper, as well as modify the tool if they'd like to add their own modules or capabilities to it. So those were the goals, and then uses, load calculation, help with system selection, heat pump system design and evaluation, and then possibly utility incentive program support and academic use. So what we decided to do was take the power of simulation and put that into a spreadsheet as best we could. Our spreadsheet uses hourly load calculations, then it has baseline and proposed mechanical system options. It looks at energy and utility cost analysis as well as life cycle cost analysis. And basically, the advantages would be to calculate hourly loads that provide an alternative to doing rule of thumb or simplified loads for equipment sizing without increasing time and effort, and simply look at multiple system types, and then first run for financial data info. So here are the systems listed in the green chart. We looked at, I guess, 11, 9, 12. That was a weird counting, but 12 total. And then we wanted to make sure we looked at different sizes, occupancy densities, and performance levels for some of the systems. What we did was run the EnergyPlus medium office reference building with all these different different system types and occupancy densities, and then scaled up system sizes and high performance and baseline. Basically, this was our simulation matrix here. Took as many mixes of these as we could. I think we got out 96 curves in the end, so we don't have all of them, but the relevant ones we're hoping are in there. We ran the simulation and got out a load curve similar to this one here on the screen. What we did was take the building load over the peak equipment size and chart it with the consumption of the equipment over the peak equipment size. So we're taking that down, running the regression curves, and that's what we're putting in our tool, which you can see here, the big table of all the system types with all their different curves. You can see we started off pulling out just cooling and heating energy use from those curves, and then we realized we wanted to take the miscellaneous cooling and heating loads, which are basically equipment, pumps, and fans, and we wanted that separate, so we ended up going back and pulling out those loads as well. So in the end, we could get the results for end uses of all of them separately, cooling, heating, and equipment. So we basically, for each system type, have the regression curves. We added, or we listed the equipment efficiencies that came with those baseline system and heat pump system types. And then we included cost per ton values, which we developed from RS means. And then we also included the estimated useful life from the ASHRAE database to include in our life cycle cost analysis. Lastly, there was a brief sensitivity study done. We ran the size and geometry, which are what's charted here, and they showed fair agreement between large, medium, and small building type. So we went ahead and didn't vary the curves based on building size. We also did that with the climate, which showed more variance, and so we're thinking, depending how different the climate is, if the tool is to be used in a different area, we might want to run curves for that as well in the future. So with all that, we came up with a user interface that's basically 2 pages for general building inputs. You can see the geometry up top there, the set points. Anything in blue we have defaulted in the tool. The yellow squares are going to be required. Obviously, if you don't have all 8 orientations for the facades, you don't need all 8 of those, but you're going to need the wall area and glazing area. All the blue cells are defaults, but they're easily overridden. So that's where you start to see some of the, it's simple because I don't need to know anything about my glass and my walls, but if I do know about that stuff, I can put my own information there. So you got set points, hours of operation, depending on which building use you choose in step 1A there, it'll default to a schedule. So if you choose office, you'll get an office schedule over there. That schedule is also customizable, and there's a whole tab to go edit the schedules for occupancy, lighting, and equipment there. So, and we can look at those later if you're interested. And then I will say this isn't the final version of the tool, so you can see in one version we had shading type, and we've changed how we calculate our glazing heat loads, so we're no longer using that. So I apologize if throughout this you see some things crossed out, but it's still a work in progress. The second page for the loads inputs, you can see the occupancy square there is all defaulted out. You don't have to put anything unless you want to. Those are based on ASHRAE tables. All the green, what do you want to call them? All the green links go back to the reference table page, so you can see where those are coming from. It'll show you the actual table, either a screenshot of the ASHRAE table or it's been put in there, hard-coded in, but all those are links that you can get more information about those inputs. So we've tried to make it very easy to adjust those. We've included all the references you should need to go take a look at, you know, what is in the infiltration. You would have a drop down where that yellow square is, giving you a tight baseline, and I don't remember what the third is. There's 3 options for infiltration, and so when you go click that link, you'll see more specifics on what those values are going to give you. So lighting, plug loads, ventilation, infiltration, and then originally we were using the balance point. We are no longer using it, but it does calculate it, so we might end up leaving that in there. Then you get 2 pages of loads results. You see the peak heating and cooling. You can see the peak of all the components separately, and then we've included under the peak heating and cooling coincident and non-coincident, just which ones are, you know, the coincident overall, and then which ones are simultaneous. The second page gives kind of an hourly plot, quick overview, the breakdown between heating versus cooling loads for the year. We've also included a lot of just unit conversions, so if you typically use 1 unit, you don't have to go convert them yourself, which can be handy. There's 1 page of mechanical system inputs. They are, I should have a pointer. Oh, I do. They're just these 5: system type and size for baseline, system type, efficiency level, and size for proposed. So we're giving you 2 options. You're going to be able to compare baseline and proposed at the end, and it's basically what you see there. There's the 8 ASHRAE system types for the baseline, and then you have four options for sizes also from ASHRAE. Same thing on the proposed. You have air source, water source, and VRF as an option. For efficiency level, you do have baseline and high performance on your proposed options, I think for all of them but water source heat pump. And currently we can't, the tool doesn't allow for changing those efficiencies. So the baseline efficiency report and proposed efficiency report, those are the numbers that were used when the curves were generated, and we have yet to do sensitivity studies on varying those efficiencies, whether we can still use those same curves with some modifications or not. So that'll be a next step, but pretty easy to choose your HVAC system, and then you get a page of results out from that showing EUI for baseline and proposed with savings, and then also the kBTU and percentage savings. We wanted to make this very graphic so you can see it at a quick glance if you need to. The tables included below, so you can pull out the details, and then the bottom right there is your electric versus gas, and then it also shows the savings between baseline and proposed. And with that, we go to energy cost results, which we've actually included 4 pages of, a bunch of charts showing annual electric, gas, dollars, and then the total energy there for whatever I had chosen back here. Packaged single zone AC versus a water source heat pump system. Through our tool, we're getting an $800 annual savings. And you can see down on the bottom right that a lot of that's coming from the natural gas. You're using a lot less natural gas there. You can also change we have defaulted average cost of electricity and gas in there. You'll probably want to change those if you're not in Idaho, but they should work. Well, it actually looks like they should already be updated depending on your schedule. A couple more graphs showing the energy versus cost distribution for the baseline and the proposed. You can see some differences there and then down below is the capital costs. So this is where we took the RS means and we did the best we could to pull out the cost per BTU and cost per square foot, kind of merge those together and get a total cost. Some future work we'd like to get with some contractors and maybe get more detailed on the costs and get a few more to add in there. But we're showing total cost for the baseline system of $35,000, total cost for proposed $40,000, and you get your incremental cost there. And with that, we go to the life cycle cost analysis, which is just showing, it looks like it'll take 7 years to recoup that with the energy savings. You can change inflation rate of money and of energy there if you choose to. But just really simple graphics trying to tell the story of what you ended up with there. And then those are just, lastly, the numbers that we're pulling out for the cash flow. We didn't want to hide anything and make it hard to go find, so we've included all of it there. You get one more page that's just a final results summary. Try to put whatever numbers you thought you might would be the most useful, I guess, on the end there. And we also leave a spot for iteration. Right now this is a single zone tool, and so it might take multiple iterations to do multiple zones if that's how we're doing it now, or you might want to look at more than one thing. So just noting what iteration it is, and then this could be your, your one-page printout that you track all those iterations with. And that is really the bulk of the interface portion of the tool. There are 6 more tabs that wouldn't really be that interesting to look at screenshots of, but we have included the calculation methods where we really want to walk through what we did so the user can understand what all's in there and just know what they're getting out. The TMY3 data is just the data from the TMY3 file, or the TMY file if you don't have a TMY3, but it has pretty detailed instructions on if you do want to switch that out. It's not difficult. We just want to make sure you're getting all the numbers you need in the right places. I can show you a screenshot of that later. But it's pretty easy. And then I mentioned all the lookup tables are very detailed, and all the references are included to go look into it more if you want. The load calc engine is where all the calculations are actually done. So that has, that's what's shown here at the bottom left. It has the hourly calculations for all the different components. And then solar hourly calculations, we had to add in that tab to do the solar loads. How I mentioned, we've changed that on the first page to get more detailed. So we're pretty happy with how that's come out. And then lastly, the schedules where I mentioned you could go customize your occupancy, lighting, and equipment schedules. Those are the remainder of the tabs. And so what we wanted to do with the tool built was go back and check, okay, we need to verify we're getting out what we're expecting to. We started with taking some existing projects and existing simulations for all 3 system types, the air source, water source, and VRF systems, and trying to back plug in that design into our tool and compare the results. What we found from that was the simulations are so detailed, it's really hard to go back and find all the inputs that you would need. So we decided instead to, or in addition I should say, to use the small office reference building and plug in, just go all at the same time, plug into all 3 tools, the same inputs, so we knew everything in there was the same and we could compare all 3 straight across. So we took the geometry and initial loads from the small office reference building, and then we plugged those into eQuest and our tool, and then as we went along we just made sure all the schedules matched exactly, and all the other inputs we just wanted to be exactly the same as far as we could tell. So some results from that are, I'll start with lighting. I'm basically going to go through all the different loads, and you can see the tools produce similar patterns, but it's clear that they calculate differently and they report different variables. This is a good example of the eQuest output is the orange, and eQuest appears to just turn off its lighting load reporting when it's in heating mode. Yes. So no, when it's in cooling. When it's in cooling, it doesn't report the lighting load. That doesn't make any sense. In heating mode. Okay, I'll get it. Well, that doesn't work for the summer week. Okay, it's clear that eQuest turns off its lighting reporting during heating or cooling because it's just calculating it differently. You can see the radiant time delay is accounted for in eQuest where it's not in EnergyPlus. You might have trouble seeing the EnergyPlus line. It is the blue line, and then the heat pump calculator is gray, and they're kind of right on top of each other, the blue and gray. You can see below on the summer week we have excuse me, an offset for daylight savings time. Our tool is not doing anything for daylight savings time, but the others are. And then what we ended up doing was adding the radiant time series to the heat pump calculator, and so we could compare those results as well. So now we're using a radiant time series within heat pump calculator. Again, with the lighting, this is just to verify, this will explain it. Cooling load, when there's a cooling load, the lighting is no longer reporting. So this bottom, you can compare the winter weeks. It seems to be shutting off right when those are coming on. So it is something to watch, and you know, graphing them out really helped to say what's going on with why are these variables different, but you can still see they're showing pretty good agreement. Occupancy, you have basically the exact same thing where eQuest shows the radiant time series, EnergyPlus doesn't. There's a few differences there. Electric equipment's the same. And then infiltration was interesting. I first charted out the flow rate just to make sure we were on board. It's pretty simple there. You can see the EnergyPlus is more detailed than the other tools, as you're getting some variation there. But then the heat gain rates vary pretty significantly for infiltration. The winter week, you're pretty close, but summer we have eQuest seems to be doing something different than the other two tools, which I didn't go much more in depth into this, but it could be similar to the lighting and occupancy loads where it just calculates it differently. It doesn't really appear like that's the case since some of them line up, but there are some differences there. Ventilation, I kind of had to go back because I didn't have, when I was putting this together, I realized I hadn't included ventilation in the building load study, so I do need to look at it further. It looks pretty obvious from these two that the EnergyPlus, or the heat pump calculator, has 1 hour before and after EnergyPlus is turning on its ventilation, so that would be that'd be input related, but something to watch out for. And then I couldn't get the eQuest results out for this, so we'll look into that a little bit further. I did check the outdoor air since you're using EPW or BEN files depending on which engine you're using, but they seem to align pretty well. And then the solar load from the glazing, this is the one that showed the most discrepancy, and you can see that the heat pump calculator was very, very high before we added the radiant time series, and that helped dampen it out pretty well. It's still quite a bit higher than the EnergyPlus, specifically in summer, and even the eQuest as well. And with that, I decided to output the direct normal irradiance to see, why we're getting so much discrepancy, if that could be part of it. It looks like in summer it does vary between the EPW and the bin file, so that's something to also be aware of. It could change your results. I was pretty surprised by that, but they didn't align, so it might explain, well, it could explain the differences between EnergyPlus and eQuest, but our tool uses the EPW file, so it doesn't make any difference between the discrepancy from the heat pump calculator and the EnergyPlus results. This is the zone temperature. So our first iteration of the heat pump calculator, the zone temperature was always at one of the set points, and we realized we needed to add in some functionality to make sure it could float similar to how systems float, and both EnergyPlus and eQuest do that. So we did update that, and it basically calculates loads for both temperature set points and then interpolates the temperature between them. But you can see there that our temperatures still change more frequently than the ones in the simulations. So they're not dampening out really like the ones in the simulation do, but they are staying within the correct ranges. And then this is just to show the set points for those are the same. And again, eQuest cancels out depending on which heating or cooling mode it's in and just goes to 0. So difference in calculation methods. So the really interesting part, I guess, the winter week for the overall total building loads seems to line up. EnergyPlus doesn't go above 0, and so that's another difference in the way it calculates. But the winter does look pretty great. The summer, there's some major differences there. Could be due to those high glazing loads again, but big differences between EnergyPlus and the other two tools. So it's interesting to me how much variance there was between EnergyPlus and eQuest, which are both widely accepted tools. So nice to know that, you know, it's good to have more information that those might not be giving you the same results. And then these are what I'm calling the preliminary energy consumption results. I did choose the same, that should be package single zone AC for system 3, a CR11 with 80% efficiency. I put that in all 3 of those, but this wasn't, this was basically just the next step from looking at the total building loads, but I didn't go in depth to any of the HVAC equipment and details of looking at this. But the heat pump calculator does seem to fall right between the EnergyPlus and eQuest, although those are there's some pretty decent discrepancies between the two. So as far as hourly loads, they seem to be, the tool seems to be in the right range, but I think that it's worth finding out more information as to, you know, which of these, you know, why is there such a difference between the tools in general. Again, in the summer, you can see that there's a pretty big difference between EnergyPlus and eQuest, but this time we're tracking more with EnergyPlus rather than eQuest, which is likely due to the fact that we used EnergyPlus for our simulations to get our energy consumption data. So you can see if we're plugging in the same loads, we should get out something similar to EnergyPlus. And then for just an overall view, these are all weekly views, so just to see the eQuest for this input with the package single zone, we got a 48.7 EY compared with a 33.9 for EnergyPlus, and then a 45.3 for our tool. So I think the big takeaway there is that there's a 15 EUI difference between eQuest and EnergyPlus, and there's probably some more digging to do there. We're pretty happy with our calculation methods for the heat pump calculator as of now because we are falling within that range of those other tools. So we are going to continue to look at the differences, and I think we'll do more studies with the simulations. but we do feel confident in definitely the load side of the tool, and then the final results as well. I did do a quick literature review for if other people have found these types of differences, and you can see there's a student's thesis here on the left that they're finding a pretty big difference between eQuest and EnergyPlus for heating, for their natural gas, and then a little discrepancy for their electric during the summer months. They've compared their results to actual data. I don't have any details about, was this calibrated to the building, or was it before or after the actual data was known, but their actual data does track with the eQuest more closely than the EnergyPlus, but again, I don't have details on that. And there was another ACEEE paper where they're showing here, I don't know if you guys can read that, but the blue line is EnergyPlus and the red and pink are both eQuest. Two different, they're calculating the cooling rate and then the heat extraction rate, so they're similar, but you can see there it's a pretty, still maybe a 25% offset between EnergyPlus and eQuest. So I don't think it was my inputs causing the difference, but I do think there are some major differences between the two tools that should be kept in mind. So highlights of our tool specifically is it's macro-free. The transparency, again, is really important to us. We're glad we could populate it with the defaults to make it more simple, but still have the ability to override those. I think the reference tables are a very valuable part of the tool, just to have those all in one place and available to use. And then it does the hourly calculations, so rather than simplifying the loads or simplifying the energy calculations, you have those detailed hourly calculations for each component. You can pull those out. And then we're also using the full simulation data from EnergyPlus. So I think those curves give an advantage in that rather than just assuming full load efficiencies or including some part load curves, we're really getting the effects, the interactive effects between other equipment and how the fans and pumps and the heating equipment is working together. So that is a plus. And then the financial analysis, I think, is a really important part as far as trying to get people to use this early on in the design stage. The way we're seeing it, we're hoping at least it can be used, is that an architect or engineer can quickly pull it up, plug in some general numbers close, whatever they have for the building in the early design stages, and say, hey, we could put in a heat pump and it only cost a little bit more, and here's your payback estimated from this tool, that it could actually be a good way to go. So tons of potential next steps. Again, more verification compared with the simulation tools. We're in the process of including residential specific inputs in kind of a residential module. It fits really well with residential since it is single zone right now, which is another one. There at the bottom, we want to add multi-zone capability to it that's not too complicated. We also want to, or I think we're going to, integrate some of our previous tools for climate design, such as cross ventilation, stack ventilation, night ventilation and thermal mass, and then the passive solar and earth tube. We want to get all those integrated into one tool so you can really do some design using it if possible. You may have seen the ground source heat pump system was grayed out. We had hoped to do that on the first iteration, but it's quite a bit more complicated than the other ones, so we still hope to do that at some point. And then improving the equipment and operating costs. I mentioned, working with some contractors, maybe even some property management to see what they're finding in the field for operating costs. And then again, the customizable efficiencies, where you don't have to just take the efficiency that is defaulted for the specific system type, but once we run some sensitivity analysis on that, we should be able to include it. Multi-zone, an easier way to do iterative analysis that maybe saves the files or something, and then additional climate and TMY data. Potential automation, we are trying to avoid macros, but we think the tool could be used for multi-zone or other climate types. Pretty easy if you just had a couple macros to switch some info out. So it's all up for discussion. And that's all I have for our heat pump calculator tool. I do have the tool if you guys would like to look at it. I don't have anything specific to show you, but does that sound good? Do you have questions? Okay.
Well, I just wanted to kind of share some of my experiences with this tool kind of from the beginning. And so for me, I'm actually today breaking ground on a new house, and my original desire was to really create something extremely innovative, net zero, just way out of the box, and very limited tools and things that were already put together to allow me to do that. But so, as we were working through the development of this tool, Kate kind of mentioned it here at the end, there's some climate design tools that IDL's produced in the past, and a lot of those things were what I was looking to include, things like earth tube, stack ventilation, thermal mass stuff. And it was real simple for me to open up this heat pump tool and get to the load calc engine and kind of see what it's doing, modify that a little bit to match what I wanted to do, and then add some tabs down here that were just those climate design tools that they had done before, and then start linking these things together so that it became real easy for me to just, with a few inputs, see, well, what would the effect on my house be, my loads, if I put more glass in, or what would it be if I threw this kind of system in versus that kind of system. And it was extremely helpful. Probably the most helpful thing for me is all these reference tables that they already have in here. You can use those for design. I mean, I noticed that one of the big reasons people don't use simulation is they say that you can't use it for design. Well, you can look at all these tables here, and then you can get to design, and that's exactly what I did. And anyway, I couldn't have gotten to a point where I could actually go build this thing without this tool, honestly. It just would have taken me a lot more time, or I would have had to hire some people to do that for me. But this is very flexible, and I'm sure every one of you guys can get into here, start looking at the formulas, looking at the tables, and really customize this to do just about anything you want. So it's really a nice kind of foundation to try and look at some things that are very innovative and may not have good tools out there to analyze yet. So I just wanted to kind of echo how useful this stuff was for me when I was really trying to do some way out of the box stuff. That's an excellent question, Tim, and that really was kind of my intent as we were not necessarily custom, but to use this when we got done with it in our incentive programs one way or another. My original idea was actually more focused towards the residential custom kind of thing, because we have, well, I'll say since it's a program I run, and we have the best custom, commercial industrial program in the world, but the residential doesn't have that option. They have prescriptive incentives, and you either take it or leave it. So my initial thought with this is maybe we could get to a custom residential program. Those discussions are still alive, and this tool is still, part of those discussions. Katie mentioned some kind of future work we might look to do on this, an investigation. But that still is definitely what I am looking to do with this, is use this tool to allow us to maybe do some more residential custom stuff, or maybe even in the small commercial where you have kind of single zone or real simple buildings, use this to estimate energy savings. So yeah, great question.
Thanks, Chris. Are there any other questions?
What do you do with here?
So we, the question was, what did we do with outside air, and what would be the difference between the units handling them or dedicated outside air? We didn't break out, I guess that would be on the load side for the simulation curves, and so we did not break out the ventilation, heating and cooling versus other heating and cooling. It could be something that, we have the load there, so we might be able to pull off a percentage and say this percentage is going to ventilation, but we haven't, I guess we haven't included anything in the tool that would separate the calculation for dedicated outside air. You can specify the ventilation rates, and they're all included in the heating and cooling, but so far there would be no, I'm just thinking through this. Yeah, all that air heating and cooling would just be on the coils. So, any other questions? I might just show you the remainder. Oh, what this?
This is Chris Dyke from Musgrove Engineering. My question was on the eQuest results.
Okay.
So at my work, we use eQuest and EnergyPlus, but so does eQuest not report it, or does it not simulate it?
As far as those values dropping to zero?
Yeah, like the ventilation, the lighting, the equipment.
I think it's just the difference in the reporting parameter. So it's just where it's calculating it and where it's reporting it. It's got to be in there, yeah. Yes, so it's just that lighting, heating load, it's not putting it in to that parameter, which in a way is helpful. It's showing you, I'm sure if you were doing different calculations, you would have just the points when you need the heating load there. So it's just interesting how the tools differ between what they're reporting versus how they're calculating it. Or I thought it was even interesting that that EnergyPlus does all the excuse me, EnergyPlus does all the radiant calculations as well, but it's not including them that early on in its process. So you're seeing the lighting load, which is basically the schedule multiplied by the lighting power density. That's all it's reporting there. Where eQuest is reporting, it's already taking that radiant fraction out and doing, some analysis, incorporating the zone to get its curve. So it's just a different reporting parameter, and probably, the different methods it needs. The EnergyPlus maybe adds all their loads up and then does the radiant at the end, and the interaction with the zone and materials. So yeah, they're both definitely great simulation tools. It's great to use any kind of simulation tool. It's just, it was surprising to me how different the results were.
Can I ask one more question?
You may.
So my other question is, complexity. So the reason we use EnergyPlus is because it's so involved and there's so many inputs, and you can really get into the nitty-gritty to what a building does. eQuest is a little more simplified. There are the same inputs, but not as many, I would say. You can't do the custom algorithms, that sort of thing. How much time does this save? And with respect to, if you're just trying to get loads real quick, this sounds like the best way to do it. But if you're trying to get a full simulation, this is probably not the right tool. But how do you compare those as far as which one's better for what situation?
Yeah, I think that's tough. From my personal experience, I would say the hard part or the time-consuming part about eQuest would be putting any specific geometry. So I think eQuest is a great tool. It's similar to this in that it has a bunch of defaults filled out. You can put in minimal inputs and still get a result out. I think eQuest is great to use early on, and I think that's kind of what this tool is for. This one would be easier to change, maybe window areas or wall areas without committing to simulating the geometry. You could still go in and say, this is about the size and geometry of my future building, and I really just want to get some energy numbers and potential dollars out to go take to maybe one of our very first meetings to say, hey, maybe you should consider heat pumps. They will probably cost you more up front, but look, we've already checked out, a similar building that it works out. You get a 10-year payback or whatever it might be. So I guess the major difference between complexity, I think, and this one has fewer inputs than eQuest, but eQuests aren't overly complicated, but you're not committing to the geometry side of things, which, I don't know. I guess in eQuest you can pick some general ones too, but yeah.
100 zones. You also have pretty tough in eQuest and EnergyPlus. How much time does it take to do 100 zones?
So probably a long time as well. It depends. I guess our first view would be to use it as put the whole building in as one zone, and then see what kind of it might be nice to in the future add like a diversity factor for some of those water source heat pump central system types to give you a little more credit for having more zones, but I don't think this would be the tool to do 100 zones just as like printing it out. Yeah, or you could do macros and just print out a bunch of zones, but yeah, it's still in progress. I think another nice thing about this tool maybe over eQuest would be the transparency. So if you wanted to get in and look at specific points in time or specific components of the load, you can really pull out, here's our peak load from the glazing. It happens at this day, at this time, and maybe I can work around that by adjusting those windows, and I don't know.
Yeah, to add a little bit on that, from my experience, this is extremely effective really early on in schematic design to do what-if scenarios, and you can do things like there will be default code U values in there maybe, and well there are, and then you might say, well, what if I double that U value? What does that do to the economics and the loads and whatnot? Or what happens if I do, triple paned low E argon glass versus double pane kind of standard stuff? And those what if scenarios, you can at least get order of magnitude information really, really quickly from this tool by doing that. So to me, that's probably the most valuable part of this tool right now. I did have a question for you, Katie.
Mm-hmm.
Is this tool available for these guys?
I am going to post a version of it next week. If any of you want this version, you are welcome to have it. It just needs a little cleaning up.
And
so
we'd love to hear your feedback on it, guys, too. I mean, like you've heard, this is kind of something we've been working on, and we've tried to vet with some different simulation programs, and have actually put it in front of an engineering firm to compare that to their load calc process and see how well this matched up with that. I was pretty happy with those results. But anyway, any other feedback you guys have, if you do take a look at it, we'd love to hear it.
Can you go through your load calculation process? Is it similar to EnergyPlus or eQuest?
Sure. So A lot of them are, you know, these first loads inputs, a lot of these come up with the final, you know, here's my envelope BTU per hour and here's my glazing. You're basically taking this maximum and then multiplying it by the schedules. So it is really, I mean, it's simple in that manner.
And the envelope and glazing are incredibly complex issues.
Yeah, so the glazing we ended up doing, oh, it's really hard to. So the glazing, there are some details you could change. The shading coefficient's set to 1 right now, but the rest of these values can be changed on the front page. And you can change this value if you want to. Oh, I've protected it. So, yeah, this is so hard. So the solar, you can just see the hourly values out of the weather file, and then you just, we've basically calculated all the angles of incident and all the geometry to get what kind of value you're going to have on the window, the cosine angle of incidence, and then we're getting out the global irradiance. So basically the only thing that complicated it is we end up with the total on the windows that's happening at that point in time, and then we add in the, or I guess this is the total, and then we add in the radiant time series based on the type of interior selections you make, medium with carpet. So there's the solar. Load calc, you can see you have all your schedules, occupancy, lighting, electrical, infiltration, and ventilation. You have all the values from the front page. They're hidden up at the top, but can be expanded easily. I should have had that shown earlier. So you have, these are basically the loads inputs that are being plugged into the schedules. I really wish I could see the whole screen here. And then you get the temperature dependent loads. So, or temperature independent first, which are just multiplied straight across, and then you get the temperature dependent loads. How we ended up doing it, you have your set points here, is you have predicted to heating set point and predicted to cooling set point, and then you basically interpolate where you're at between those, which is interesting because I think it was eQuest that as an output had predicted to heating and predicted to cooling. So I'm guessing they do a similar thing to say what your load is going to be for each.
Is this hourly?
What?
Is this done hourly?
Yes, hourly.
So that could be the simulation results.
Yeah, that you don't have four time step. Yep, and that would probably help dampen it out too instead of jumping back and forth between.
Yeah, I think this load calculation and just that alone, I think is a great tool. We're always trying to come up with spreadsheet calculation tools. Great starting point.
Yeah, I think it's fairly, for the inputs you're, committing to, it's not that much time to be able to get out the hourly results there. So, yeah.
I'm sorry, Kate, I need to leave.
Oh, no, feel free. Yeah, thank you for coming. I think we're just about done unless anyone else has any other questions. Any online questions? None there? All right, well, thank you all for coming. And like I said, if you really want the tool today, I can give it to you, but we'll have it posted, and I'll make sure there's a link from the BSUG page, and I'll probably send something out in the newsletter as well. But it's available. If you do try it, I'd love to get your feedback anytime, so let me know. And That's all we have, yeah. Please fill out your evaluations, and thanks for coming. Is there anything else? All right. Oh, yeah. Yes, it should be third Wednesday of next month. We're hoping to get back on track, and we're hoping it's Corey Squires, I think it was. So, yes, I'll send out details and make sure you're on all our emails and attending. So, thank you guys.